So today we will discuss the allenes. So these allenes so when three or more adjacent carbon atoms when three or more adjacent carbon atom in a molecule are bonded by double bonds, the compound is called cumulene. So the cumulene is the general name. The compound is called cumulene. So this cumulene name is derived from cumulative double bond. So allene is the simplest example of cumulene. So this allene has two cumulative double bonds, right? So at the terminal carbon, we have two H groups. So if we number these carbons, let us number these 1, 2, and 3. The hydrogens at carbon number 3 are exactly the plane of this carbon 3 is exactly perpendicular to the plane of carbon 1. So you can say these two are in another plane, these two hydrogens. So if this is the one plane, which you suppose this is the plane of paper, then the second plane must be oriented in such a way that it is exactly perpendicular to the first plane, which we have represented like this. So let us draw the second plane again. So this plane is exactly perpendicular to the blue one. Okay. So allene ਦੇ ਜਿਹੜੇ terminal methylene group ਨੇ, they are perpendicular to each other. Okay. So these two methylene groups, they are perpendicular to each other, and so let us understand this by drawing the orbital diagram. So suppose we have this carbon. So the center carbon is having the p orbital, one in y direction and other one is in the x direction. Okay. So the bonding of this is in such a way that the lobe of this carbon is like this, whereas the lobe of second carbon, terminal carbon, is oriented in this direction. Okay, so this will form bond with this one, which is parallel to this, and the second carbon will form bond in perpendicular direction. Okay, so these two terminal carbons, these are sp2 hybridized trigonal structure hai the. Okay, so both the carbons are sp2 hybridized, whereas this center one is sp hybridized in allene. Okay, so thus the central carbon atom has two bi bonds because both the p orbitals of center one are overlapping with the p orbitals of other one. So center one has two pi bonds. So allene, which have two different groups, A, B, double bond, C, double bond, C, A, B, right? So this is chiral due to presence of chiral plane if A is not equal to B, means these two groups are not same, then only this allene is chiral. Although these two groups on this terminal are same. So this may be same, 1 3 the same group ਲੱਗ ਸਕਦੇ ਆ, but carbon 1 ਤੇ ਜਿਹੜੇ ਦੋਨੋਂ groups ਲੱਗੇ, A does not equal to B, then only these are chiral. This is so because when we draw the mirror images of allene, so these mirror images are non-superimposable on each other. Suppose this is A, this is B. एक plane च आ गया and this is on another plane, right? So when we draw its mirror image, so this side will come here, C double bond C double bond C, and we will be having A here, B here, and this one goes to this direction, and this B is here. We are drawing like this. So these structure 1 and structure 2 are non-superimposable mirror images. So for this reason, the allenes are chiral in nature and they exist as enantiomers. ਹੁਣ ਇਹਨਾਂ ਚ center ਤੇ ਹੈ ਨਹੀਂ ਤਾਂ ਵੀ ਇਹ chiral ਨੇ. This is due to presence of chiral axis. They are these allenes are chiral in nature. Okay, so we can write this: allenes have chiral axis as their element of chirality. For this reason, they are chiral in nature. Okay, so let us consider the allenes of two types. The first type is, we have already explained that one, C double bond C, A, B. So this is chiral when A is not equal to B. So if we have the arene, another set of allene which has, so instead of AB we have different groups B and E. So this is also a chiral in nature. Okay, so they both the allenes will exhibit enantiomerism. Okay, so let us take the example, then the picture will be more clear to you. So suppose we have this second type ਦੀ ਜਿਹੜੀ allene ਹੈ, ਇੱਕ carbon ਤੇ Cl ਤੇ H ਲੱਗੇ ਹੋਏ, whereas on another carbon we have methyl group and CME thrice. CME thrice. So this is chiral because when we draw their mirror images, they are non-superimposable. Okay, so let us take the type 1 example. Type 1 example is C double bond C. So here we have H group, COOH. Similarly, on second one we have H and COOH. So this is also chiral, right? So ਇਹ ਦੋ group same नहीं होने चाहिए ਤਾਂ allene है chiral, otherwise it is chiral in nature. Okay. So the spatial arrangement of, now let us write one more important thing. The spatial arrangement of double bonds in cumulene having an odd number of double bonds is such that the S case की सी even number of double bonds सी. So if cumulene have CUMULENE, okay, this cumulene will have odd number of double bonds. An odd number हो गया means of this type. So in this case, what will happen now? these two groups are not perpendicular terminal the case, they are in same plane, right? So they lie in same plane. So thus they have, if A and B on both the carbons are terminal carbon ਦੋਨਾਂ ਤੇ ਜੇ group same ਲੱਗੇ ਹੋਏ ਆ, then this molecule is achiral. ਠੀਕ ਹੈ, ਰੀਜ਼ਨ ਕੀ ਹੈ? they are in same plane. ठीक है, ਜਦੋਂ ਇਹਦੀ mirror image draw ਕਰੋਗੇ they are superimposable on each other. Okay, so when your cumulene have odd number of double bond, then this B groups on both the terminal carbon should be different to exhibit the enantiomerism. Okay, so one more thing, please write down. If the substituent on each carbon are different, then only the cumulene with odd number of double bond will exhibit isomerism, right? So let us take one example. Suppose you have this type of cumulene, C double bond, C double bond, C double bond, C. So here now is now the double bonds are okay. So the structure, we have to determine whether this cumulene is optically active or not, means it is chiral or not. So first what we will do, we will calculate the number of double bond. 1, 2, 3, 4. So it is having even number of double bond. This means these two planes are perpendicular to each other, right? So J groups same ne dono terminal, then also it is chiral. So this cumulene is chiral in nature. Okay. So now let us discuss another category. So if one of the double bond of allene is replaced by some ring, ठीक है, जे कोई ring भी आ जाए ਤਾਂ ਵੀ rotation ਜਿਹੜੀ ਹੈ it is hindered. ठीक है, so basic geometry of the molecule will not change and they must exhibit the enantiomerism. So let us take the example of this case. Suppose we have this type of system. So instead of this allene that double bond jada hai, I'm highlighting with yellow one. So this is replaced by now the ring system. ठीक है, so as cyclohexane ring आ गई ਤੇ ਇਹਦੇ ਇੱਥੇ terminal ਤੇ methyl ਲੱਗਾ ਹੋਇਆ and here is we are having H double bond H COH. So this molecule is also chiral in nature, right? So here this double bond is replaced by this cyclohexane ring. Okay. So they also exhibit the enantiomer. So let us now take another class of compound which exhibit stereoisomerism, and that is known as spirons. So these spirons, if the two double bonds of allenes are replaced by ring systems, the resulting molecules are known as spirins. Resulting molecules are known as spirins. Okay. So पहले ਆਪਾਂ ਇੱਕ ਰਿੰਗ ਸਿਸਟਮ ਨਾਲ ਡਬਲ ਬੌਂਡ ਇੱਕ ਡਬਲ ਬੌਂਡ ਰਿਪਲੇਸ ਕੀਤਾ ਸੀ ਐਲੀਨ ਦਾ ਰਿੰਗ ਸਿਸਟਮ ਨਾਲ, ਜੇ ਦੋਨੋਂ ਹੀ ਰਿਪਲੇਸਡ ਹੋਣ Such type of molecules are known as spirons, and they also exhibit the spirane also exhibit the enantiomerism. So let us take N compounds, no spirons, no we also call them as spiro compounds. Spiro compounds. Okay. So let us take the example. So suppose we have this type of allene and we are going to replace both the double bond by a ring system. So X and Y, तो plane दोनों different क्योंकि even number of hydrogens are there. So now we will replace this double bond and this double bond by a ring. So let us draw the structure. Suppose we have this type of ring. ठीक है एक रिंग आ गई सेकेंड रिंग जड़ी है डबल बॉन्ड नाल जड़ी रिप्लेस कीती it is having this type of structure and here the x will remain as such ਜਿੱਦਾਂ ਲੀਨ ਚ ਸੀ y is here and here we will write x and y. So these molecules are also chiral and this is spirane or spiro compound. So we call it as spiranes. So let us draw its mirror image. Okay. So mirror image when we will draw, this x will now come to the left side, y. Okay. This solid ring, blue one, and here we have yellow one. And x and y will remain as such. So these have non-superimposable mirror images and hence they are chiral in nature. So जो conditions allenes वास्ते सी chirality वास्ते same conditions are applicable to the spiranes also. So in the spiranes these two rings are perpendicular to each other means they are in different plane. Okay, so for this reason they exhibit the enantiomerism. So in this case also the element of chirality is presence of chiral axis in the molecule. The presence of chiral axis in the molecule led to the enantiomerism in spirene. Same exactly same as जिस तरह allenes है. So let us take the example. Suppose we have this type of compound in which we have NH2 जो एलीन पे applicable है वो भी spirens पे applicable है. So now you can write is it chiral or not? So because it is having two rings means even number of double bond of allenes. So they are perpendicular to each other although they have same substitution, right? In spite of this fact these are chiral. Okay. So instead of two rings if we have three rings here then the situation is different means ਉਹੀ ਜੋ एलीन च apply ਹੁੰਦਾ ਸੀ if A and B these are equal then it is A chiral. So instead of AB if we have C here and D then it is chiral in nature. Okay, so सब कुछ same है जिस तरह की एलीन्स में. So in this case we have chiral axis. Now let us take another class of compounds which are known as biphenyls. So these biphenyls also exhibit the stereoisomerism. So before discussing this, so let us define one term which is known as atropisomers. Atropisomers, or you can say atropisomers. So these are basically isolable stereoisomers resulting from the resulting from the from the sorry resulting from the sorry resulting from restricted rotation about carbon carbon single bond, right? So these isomers are known as atropisomerism isomers, like, right? So in their geometry, atropisomers approach allene derivative and have the axis of chirality, but not center of chirality. So in cases ਚ ਵੀ ਕੀ ਹੁੰਦਾ, we have axis of chirality, not center. Axis is there, not center is there. Okay. So its example is atropisomers. The example है biphenyls. So biphenyls ਚ ਕੀ ਹੁੰਦਾ, two rings are connected by carbon carbon single bond. ਤੇ ਜਿਹੜੀ ਇਹਦੇ around rotation ਦੇ carbon carbon single bond ਦੇ around rotation ਜਿਹੜੀ ਆ ਉਹ rings ਦੀ substitution pattern ਕਰਕੇ restrict ਹੋ ਜਾਂਦੀ ਹੈ, ਉਹ rotate ਨਹੀਂ ਹੋ ਪਾਉਂਦੀਆਂ, ਜਿਹਦੇ ਕਰਕੇ ਇਹਨਾਂ ਚ chirality ਆ ਜਾਂਦੀ ਹੈ. So let us discuss this thing. So suitably substituted biphenyls exhibit enantiomerism due to presence of chiral axis, and they are atropisomers because they exhibit enantiomerism due to restricted rotation about the carbon-carbon single bond of two diphenyl rings. So suppose we have this type of system. This is diphenyl. Okay. So now substitution is there. So in this ring we have A, here also A, B and B. Okay. ਹੁਣ ਇਹ ਜਿਹੜੀ ਬਾਈਫਿਨਾਈਲ ਹੈ ਇਹਦੇ ਅਰਾਊਂਡ ਰੋਟੇਸ਼ਨ ਕਿਸ ਤਰ੍ਹਾਂ ਰਿਸਟ੍ਰਿਕਟ ਹੋ ਸਕਦੀ ਹੈ if we have some substituent present like I have shown with pink color, then only it can show the ਬਲਕਿ substituent ਹੋਣ ਇਹਦੀ ਕਿਹੜੀ ਪੋਜੀਸ਼ਨ ਤੇ ortho position ਤੇ all the ortho positions are occupied by bulky substituent, then only the rotation about this carbon carbon single bond is restricted. ਹੁਣ ਜਦੋਂ ਕਾਰਬਨ ਕਾਰਬਨ ਸਿੰਗਲ ਬੌਂਡ ਦੇ ਅਰਾਊਂਡ ਰੋਟੇਸ਼ਨ ਰਿਸਟ੍ਰਿਕਟ ਹੋ ਗਈ, ਸੋ ਦੈਟ ਮੀਨਸ ਹੁਣ ਇਹ ਜਦੋਂ ਬਲਕੀ ਗਰੁੱਪ ਲੱਗੇ ਹੋਏ ਆ ਤੇ ਇਹਨਾਂ ਦੀ ਕੋਸ਼ਿਸ਼ ਮੋਸਟ ਸਟੇਬਲ ਕਨਫਰਮੇਸ਼ਨ ਉਹੀ ਹੋਏਗੀ ਜਿਸ ਕਨਫਰਮੇਸ਼ਨ ਚ A ਤੇ B ਜਿਹੜੇ ਨੇ ਦੇ ਆਰ ਮੈਕਸਿਮਮ ਅਪਾਰਟ, ਤੇ ਉਹ ਮੈਕਸਿਮਮ ਅਪਾਰਟ ਵਾਲਾ ਜਿਹੜਾ ਐਂਗਲ ਹੈ that is 90 degree, means both the rings are perpendicular to each other. Rings are perpendicular to each other, then only the steric hindrance between the bulky groups will be minimum. Okay. So on perpendicular hone karke we can draw the mirror images which are not superimposable on each other, and due to this they become chiral in nature. So these biphenyls can show isomerism only if they satisfy two conditions, right? So two conditions are required for the this chirality of these biphenyl ring system. So let us take these two conditions. So the first condition is each ring of biphenyl must be unsymmetrically substituted. Must be. So this is the condition number 1. Right? So the system we require is having the structure like this. So ਇਹ ਦੋਨੋਂ ring आपस ਚ ਕੀ ਹੋਏਗਾ? They are perpendicular to each other. So unsymmetrical substitution होनी चाहिए है. So unsymmetrical ਦਾ मतलब let us consider 2-3 cases. Suppose if we have this type of system, right? This is first one and second वाला जड़ा case है, suppose it is like this. We have this type of substitution A. Here is A. So we will draw the axis B. So this is the second case. And the third situation is we have on one ring A and B groups, whereas on the another ring we have this type of substitution. It is different from ring A. So let us consider all three cases. This is the second case. And this one is the third case. So in the first case, this is not resolvable. Not resolvable. The reason is both the rings have plane of symmetry, means one half is exactly mirror image of other half. So it is not chiral. So if we look at this second ring system, this does not have plane of symmetry. Whereas third one also do not have plane of symmetry. So both of these 2 and 3 are resolvable and they exist as enantiomers. Okay, so plane of symmetry nahi hai, they are resolvable. So this is the first condition. Both the rings should be unsymmetrically substituted. The second condition is both rings must be substituted in ortho position. So ortho position ਉਹਨਾਂ ਦੀਆਂ substituted ਹੋਣੀਆਂ ਚਾਹੀਦੀਆਂ ਹੈ. Then only there is rotation about carbon single bond is restricted. ठीक है? And this substituent must have larger size. bulky होना चाहिए है. Substituent must have larger size. Okay. So when the substituent have larger size, steric hindrance is there. So the biphenyl lock in one conformation. Free rotation does not exist. So jadon free rotation nahi hui, then only it is possible to get the optically active biphenyls. Okay. So Let us do some examples. Suppose we have this system diphenic acid. So this diphenic acid COOH, it has another COOH. So if you look at this, so if we will look at this molecule is optically inactive. Another key reason है, it has plane of symmetry. Means if we draw like this plane, one half is exactly mirror image of other half. Okay. So if we have another type of molecule in which we have two COOH group at two different sides ortho of rings. So this molecule is also optically inactive because it is having center of symmetry. So it is having center of symmetry. Center of symmetry का मतलब क्या है? If we take this as center and we draw one line, so we are meeting here COH and exactly same distance we are getting another COH. So this molecule has center of symmetry. So it is not optically active. Okay. This molecule is not optically active. ਹੁਣ ਇਸ ਕੇਸ ਚ ਕਿਉਂ ਸੈਂਟਰ ਆਫ ਸਿਮਟਰੀ ਆਇਆ ਬਿਕੋਜ਼ ਇਹ ਦੋਨੋਂ ਰਿੰਗਸ ਜਿਹੜੀਆਂ ਨੇ ਇੱਕੋ ਪਲੇਨ ਚ ਆ ਗਈਆਂ ਉਹਦਾ ਰੀਜ਼ਨ ਕੀ ਸੀ COH ਇਜ਼ ਨਾਟ ਲਾਰਜ ਇਨਫ ਕਿ ਇਹ ਇੱਕ ਦੂਜੇ ਨੂੰ ਮੈਕਸਿਮਮ ਅਪਾਰਟ ਰੱਖ ਸਕੇ so similarly instead of COH if we have SO3H then in that case so we have SO3H here and this SO3H group is larger enough that these two rings are perpendicular to each other. So in that case, no center of symmetry is there. So ਇਹਨਾਂ ਦੋਨਾਂ ਨੂੰ ਜੇ ਆਪਾਂ ਕੰਪੇਅਰ ਕਰੀਏ ਇਸ ਕੇਸ 'ਚ ਸੈਂਟਰ ਆਫ ਸਿਮਟਰੀ ਕਿਉਂ ਆਇਆ ਬਿਕੋਜ਼ ਇਹ ਦੋਨੋਂ ਰਿੰਗਸ ਜਿਹੜੀਆਂ ਨੇ ਦੇ ਆਰ ਇਨ ਵਨ ਪਲੇਨ ਰੀਜ਼ਨ COH ਗਰੁੱਪ ਇੰਨਾ ਬਲਕੀ ਨਹੀਂ ਹੈ but SO3H group is sufficiently bulky that these two rings are now in perpendicular planes, right? So then there is not any center of symmetry. Equidistance से move करके सानू SO3H नहीं मिलेगा. Okay, so let us do one more example. So ਤੁਹਾਡੀ book ਚ ਕਿੰਨੀਆਂ example ਦਿੱਤੀਆਂ ਹੋਈਆਂ you can do that. I will discuss only one more. So suppose we have this type of ring system. COOH group is there. Now we have placed a nitro and we have another ring. Now this ring is perpendicular to each other. So COOH. Okay. So this compound is optically active because it does not have center of symmetry. So we can draw its mirror image like this. So this nitro comes here. COOH group comes here. And here we are having another ring. And COOHs, right? So this structure exists in enantiomeric form. Okay. ਹੁਣ ਇਸ ਕੇਸ ਚ ਨਾਈਟ੍ਰੋ ਤੇ ਕਾਰਬੋਕਸਿਲਿਕ ਗਰੁੱਪਸ ਜਿਹੜੇ ਨੇ they are bulky enough that the two that the two rings are now in different plane and they do not have center of symmetry. So you can see another example yourself. So this is all about the center of symmetry in stereochemistry in biphenyls and allenes. Okay.